Presentation at Innovators Corner is going to be by Mr. Daniel Carter from the Aviation Missile and Research Development Engineering Center, and it will be on modular missile technologies.
To the right. Okay, thanks. Okay. All right, good evening. Daniel Carter. I'm with AMRDEC, and I'm the project lead for Modular Missile Technologies, or MMT. And so why modular missile technology? Why are we looking into this? Well, Army Aviation is in the need of, they need lightweight munitions for both their manned platforms, rotary wing, and unmanned aerial systems for both current platforms and future. And also for a system that gives them the ability to reach out and do multiple missions with a single system. Also, to look into this, it's trying to reduce the life cycle cost or the overall cost of a system. So here you see in the center of the picture, we've basically got 4 core subsystems that make up what we're doing with MMT, which is their CAS, the GEU, our guidance electronic system, control actuation system, or the CAS, payload, and the motor. From that, these four subsystems, as you can see the arrows, the way they're broken out and shifted around, we're able to reorder this system to create a missile that can achieve different missions based on the requirements. We're building it to a 70 millimeter, 25-pound tube-launched missile, and this is all based around the open architecture system. So initially, the tailorability is kind of built around the payload. Now, Army, they require more than just a single type of payload, so we're looking at see if there's my animation, okay. So we're building these 5 subsystems, the 4 core ones that we're building, and then there's so secret technologies are kind of, they're separate S&T programs that are following along and tracking along with us, and we're integrating in as we move along and eventually close the loop around those. But right now, the bottom 4 that you see, the CAS, the GEU, the payload, and the motor, or the propulsion, is the main focus. Now, Army Aviation, in order to meet current and typical engagement scenarios where it's the air-to-ground type scenario, we're building to that, but also thinking outside and further down the road of an air-to-air type scenario. And so what we're doing right now is looking at a blast frag with a semi-active laser or a SAL seeker, but following on to future payload systems, we're still keeping in mind that there's a need for lethal systems or payloads and non-lethal, where we've got the blast frag, a penetrating type warhead, a flechette, and then you get into non-lethals where you have smoke, flares, and such. So we're looking into, so part of the open architecture keeps in mind that the evolution or the tailorability of this system needs to be able to swap the warhead out to meet the multiple types of missions for future and current as well. Now, also this tailorability is not just the payload as all alone. We're also looking at the seeker type technology or the guidance system of it. Right now we are building to have the SAL seeker on board, but also we're keeping in mind that there's other means or needs for guidance. You may want just a GPS guided or GPS aided or inertial only, and there's still the need that the pilot or the gunner is still going to need the unguided round. So in order to achieve the unguided, of course, the CAS is removed, and that's one of the things that we have tested in some flight tests already, a ballistic test vehicle where you basically added an erodible spin vane. Since we don't have control surfaces, we have to be able to spin it up. So there's a slight modification that has to be made to the motor that we actually incorporated in the design, so it's a pretty simple changeover. Now, evolution of the system. Starting out with just the SAL seeker here that we're building to, evolving the system to meet other scenarios. You know, right now, common Army aviation is an air-to-ground engagement system or engagement scenarios, but what about the future? Let's evolve this out, and what can we get it to? We'll start adding in, can we swap the seeker out? Let's put a infrared imaging infrared seeker, I2R. Let's add that to the system and start evolving out to where we can do an air-to-air engagement. Well, what else can we do? In MMT, where we've got the common bus that runs through the system, that's part of the design here, is that everybody ties into the same power and data feed. So let's start looking at what else we can change. You know, by having that, it allows us to be able to manipulate not just the seeker systems or the payloads that I've talked about, but also let's start evolving this and adding in more agility and increasing the range by, instead of just having a single pulse min smoke motor, what if we have a dual pulse where your first pulse is a min smoke and then followed on by a smoky propellant or a smoky pulse that gives you a higher SP and pushes the system out further or increases the agility of the system for in-game maneuverability. Then the next step up, what if we start looking more into evolving the payload system away from the traditional ones that we've talked about, but what if we start combining blast frag with penetrating capability? And the CAS and the GEU, they remain. We'll keep those, but let's take the SAL seeker and the I2R and start combining that and creating a dual mode seeker, and start evolving this into a future system that we can hand over to the pilots or to the user and allow them to have a single system that has multiple engagement capabilities, but ultimately reducing the life cycle cost by having increased stowed kills by having a system that's able to engage both air to ground and air to air. So one system to kind of carry out multiple scenarios. But when MMT is developed, you know, we are building around that 70 millimeter size. We didn't intend it to be just a 70 millimeter size from the start. We want it to be more. So that's where scalability comes in. We tried to think about, as we're building this system, how can you push it out and beyond rather than just a 275 diameter? Let's move it out. Can you scale this technology up? So we tried to keep in mind the architecture as we built it, that it's amenable to a bigger system, whatever diameter it may be or whatever mission set, or whatever whether it be ground-based or close combat or ground-based or long-range precision fires. Don't restrict it to just aviation systems as alone, but also what if close combat type scenarios require this type of technology. So we want it to be amenable to other avenues as well. So we've tried to keep that in mind as we went forward, and I believe that's about all I have. I guess we'll open it up to questions. Thank you for your time.